Good morning. The topic of the discussion is recent advances in transmission insulators. So, as we look into the before going to the topic, we will look into the brief introduction about the development of the power transmission in the country as well as globally. This graph shows you the growth or the development of the power transmission across the globe, where you see at an increasing about 3% per year, the voltage the transmission voltage has been seen increasing since 1900s. So, presently we are in the country operating at 765 kV levels, and at 1200 kV experimentation is also in progress. This is how the transmission technology which is developed in the country. So, this graph shows since 1977, where we were operating at 220 kilovolts. Gradually in 90s we were operating at 400 kV. Further in 2000 we started using HVDC. Prior to that we were using HVDC, but to an extent 2000 we started using 500 kV HVDC. HVDC is much more beneficial for long distance transmission, where huge power can be transmitted over long distances. That is one of the major advantages of going in for HVDC. Presently in the country we have several lines which are operating at 500 kV and also at 800 kV HVDC, which is of world's longest multi-terminal, which has been in operation from Arunachal to Agra. So, presently we are towards the AC side, we are operating several 765 kV transmission lines. HVDC we are at 800 kV transmission system is in operation, and requirement of the power has been more and more. That is the reason the 1200 kV lines are being planned, and experimental station at Bina in Madhya Pradesh, which is also the world's largest voltage level at 1200 kV. The operation or the experimentation is in progress for last 5 to 6 years by various private manufacturers, government organizations, and the public sector industry. So, the transmission, when you look into the transmission standard operating voltages across the globe, so the voltages adopted for transmission, particularly for bulk power, have to conform to the standard specifications for all the which are to be formulated in all the countries. As this is very important, because the manufacturers and the utilities will have to be following these standards, which is a very necessary part, particularly in view of the import, export, and also useful to the domestic manufacturers. In India, as per the Indian standards, line to line voltages adopted are as the following. We have a nominal system voltages and also the maximum operating voltages. So, the nominal operating voltages are shown for 132 kV, the maximum operating being 145 kilovolts. Similarly, for 220 it is 245, and for 400 kV it is 420 kilovolts, and for 765 it is 800 is the maximum operating voltage. Similarly, for 1200 kV maximum voltage, 1150 is the nominal system voltage. So, what does this give? This maximum operating voltage specified here in no case that should exceed any part of the system, because the insulation levels are designed for any equipment. It could be the transmission components or the substation equipment or any other operating at these voltages have to adhere to these insulation levels, and this design is being based on these values. So, it is helpful for both manufacturers as well as for the utility personnel to follow this standard voltage levels. So, when you look into the graph or the chart here which is presented, this gives a very clear idea of the power intensity in megawatt per meter for different voltage levels. This gives an idea like for 132 kV system, what should be the right of way, that is the towers. Tower, the clearances from the midpoint of the tower to the either side. So, the right of way for a 132 kilovolt system is 27 meters, and what could the capacity which it can transfer the power, it is somewhere between 70 to 80 megawatts. So, you can look into this. As the voltage level increases, the right of way also increases, the tower height also increases, and the capacity to transfer the power could also be much advantageous in going in for very high voltages. So, you say in case of a 765 kV system, the right of way, a minimum right of way required is somewhere around 64 meters, and the power transfer can be 2500 to 3000 or 2500 to 3000 megawatts. This is the power which could be transmitted. So, but for the same voltage level, when you look at plus minus 800 kV DC, so the right of way and the power transfer capability for DC is much higher in compared to the AC level. That is one of the advantage of going in for long distance transmission, apart from several advantages. So, you can transfer the bulk power anywhere between 6000 to 6500 megawatts in case of 800 kV system, and that is being the advantage. So, this gives an idea the minimum right of way for a towers to be followed for a voltage levels, and the capacity of the transfer of power which takes place at various voltage levels. These are a very important information, recent information, the typical all India load curve. So, how much is the power we are consuming in the country. So, this very clearly gives you the information where you can see the y axis being the gigawatts and x axis being the time in a day. The consumption, if you take a typical variation for the all India curve, it shows in the morning there is a decline and it starts rising after in the morning, and it reaches a peak somewhere between 8 to 12 o'clock, or it could be this range where the morning peak occurs. Then because there is a small change or the drop in the consumption, and again after a certain period of time there is a peak which is again says as evening peak, which it shoots up as a requirement, and again steadily it comes down. So, this curve gives an idea of the gigawatt consumption in the country, an average value in the country. So, such huge amount of power is being consumed, where we require somewhere around 136 gigawatts. The second graph here, it shows the energy consumption, how the growth has happened over the period of time in comparison from 2008 to the present. You can see the energy in million units in the y axis, and the energy which is shown towards the x axis, how it is being increased over the time. This is the time is the x axis, and energy in million units in the y axis. You can see that steadily there is an increasing in the energy growth consumption in the country. So, somewhere in December 2017 you can see the energy requirement is somewhere 3350 million units, which we are presently being consuming. So, it is a very huge requirement of energy for various purposes. So, what are the purposes which the energy is being consumed? So, this is again an important graph where it shows you how the consumption over a period of time. Again you can see from 1960s up to 2013 how the percentage of electricity consumption, the y axis shows you the percentage of electricity consumption. So, initially when you carefully look, the major consumer is being the industries, the other being the agriculture activity, the domestic activity, and the traction, the commercial, and many other small requirements. So, this graph very clearly indicates over a period of time how the consumption or the percentage of electricity consumption has been changing. When you carefully look, initially the 70% of the consumption was because of the industry level, that has been steadily decreased, and again there is a small increase at the present stage. But whereas the agriculture activity, initially it could be because many of the places where electricity was not reaching during the early 1960s 70s. So, as the electricity has been reaching the places, so agriculture activity has been picked up, and there is again the consumption of agriculture activity going around somewhere between 20 to 25%. So, then domestic, again domestic, it depends, we have seen the steady growth in the domestic requirement of the consumption. This is happening, and here again it is anywhere between 20 to 25% of the total consumption of electricity which is happening. So, traction, I can see almost it is a steady thing, even though there are several requirements which newer metros have come up, but the requirement of traction is almost looking to be a steady somewhere around 2 to 3% of the total consumption which is happening. So, there are other units which also consume. This could be many other activities which electricity consumption is being carried out. So, this gives the broader information about the percentage of electricity consumption for various loads. So, very important information. So, now looking into the requirements, when you have an entire country which is being linked, and in India the transmission network has been steadily growing over a period of time. Several initiatives by the government of India has been taken up and to see that the electricity reaches all the corners of the country. So, and not only the electricity reaching the large and it has to see that the generation points which are located depending upon the resources availability. So, these generation points to the load centers, the transmission plays a very important part. So, this transmission has to be done over a very long distances, and the distances, in case it exceeds a certain limit of say 400 kilometers, economically and technically it is much better to go in for HVDC systems. So, we are also having several HVDC transmission lines in the country. So, the map gives an indication various transmission network which is happening in the country, and newer lines which are being also under constructions or proposed are also being shown for voltage levels starting from 132 kV to 765 kV AC and also HVDC lines. So, lot of initiatives from the government towards the power sector for the installation of newer lines, and also upgradation of the existing transmission lines is being taken up. So, very important information. And when you looked earlier about the entire nation, the network which was spreading, I mentioned about the availability of resources that plays a very important role in setting up the generating units, and later on the transmission which happens through the transmission network. Here again the depends upon the transmission, again it is mainly on the operation of the grids. We have in the country presently a single grid since December 13, we have which we call as one nation one grid, which operates at one frequency. But when you just look back, we were operating at 5 regional grids: the northern region, eastern region, western, southern and northeastern region. These were the 5 grids which are being operated. Here when you look into that, the peculiarities happen to be different for each region. So, that is the reason we had to go in for a single grid, which would be much helpful for the entire operation of the country. You can see the northern grid particularly which shows mainly the snow fed region here, which is highly weather sensitive loads and also adverse weather conditions. So, the fog and dust storm are more during the monsoon and conditions there. In case of northeastern region, very low load, not many industries are available, but very high hydro potential. So, several rivers are there, you have lot of hydro potential where you can generate hydropower in this northeastern region. But there is an evacuation problem. When you carefully look here, a small space which from the northeastern towards the eastern region, you have somewhere around 24 to 25 kilometers is the small space or where you have. So, the evacuation from northeast to the main grid is a really challenge to transfer the huge amount of power. So, when you come back to eastern region, again eastern region consists of a low load, and but this region has plenty of coal reserves. It could be in Jharkhand, Bihar and many of these states where these thermal generation is possible. Lot of coal reserves are available abundantly. So, similarly the western region, you see lot of industrial load and agriculture activity which is happening in Maharashtra, Madhya Pradesh and many of these aspects. And in the southern you can see there is a high load, that is more than 40% of the agriculture load in the southern region, and mainly the rivers which are available. Again it depends on the monsoon. So, the hydro generation typically depends on the availability of the flow for the generation of hydropower. So, that is the reason where we have resources at some particular places, requirement major requirement at many other states. So, here the transmission system plays an important role. The generation stations could be of thermal, nuclear, hydro or recently the wind and renewables. So, these generation has to reach to the load centers where typically transmission system comes into a play, and the transmission system consisting of the transmission conductors, the transmission tower, the transmission insulators, several of these things play a very important role here. So, we will be carefully looking into the important properties pertaining to the insulation, the outdoor insulation, what are the type of insulators which are being used for the transmission, how are these manufactured, what are the design principles pertaining to this, we will be looking into this aspect. So, these are the important components in the transmission system. I have earlier mentioned about this aspect. So, you have a tower which depending upon the voltage level the tower is designed, and you have the conductors here. Again the conductors up to 132 kV system could be a single conductor, for 220 kV it could be a twin, for 400 kV there could be a 4 bundle conductor, and above 400 kV 765 it could be 6 conductor or 8 conductor. So, that is how the conductor configuration is being done, and you have an earth wire on the top of the towers which is mainly used for the shielding purpose in case of lightning activity where the over voltages should not develop and cause the problems related to the transformers in the substations and other equipments which are placed. So, you have a earth wire or a ground wire, then you have hardware fittings. Hardware fittings are basically the corona control rings, it could be the dampers, it could be the spacers. So, several of these things constitute hardware fittings or accessories which are part of the transmission system and very important components. So, each component in the transmission system is very important, and equal amount of care and has to be taken in the proper design of these components. So, the tower, the foundations depending upon where the location of the tower is also important. So, insulators which are very important component of the transmission system is to be discussed, and this forms the important part of the transmission system where we will be looking into the type of insulator, how this insulator design has been started being used, what are the materials which are being used for the insulators for the overhead transmission system, and what are the recent advances in this technology which are being adopted at a very high voltage levels. So, when we look into the history of transmission insulators, these insulators basically grew out of the needs of telegraph industry. So, initially before the power industry, the telegraph industry was in place. These porcelain or initially the glass type of insulators, which were known as the pin type of insulators, were started being used in late 1700s and early 1800s. So, during 1840s to 50s, before the actual insulators were tried or designed, the people were using the glass plates as an insulating material for the telegraphic lines. So, there were several trials with different materials. Initially people have tried out with wood as insulating, cement, porcelain, beeswax. Lot of trial errors have been done, and ultimately it was found that porcelain and glass perform much better, and then people thought about how the porcelain and glass can be modified and how this can be used for the insulation aspects. So, in 1900s, the early 1900s, a decade or two, 1900 to 1920s, we saw the application of voltages increased, the insulator designs became complex. So, when the voltage level started going higher, so initially it was say 11 kV, then 66. When the voltage level started going up, the insulator design became complex. So, the insulator became an important part which had to be considered for proper design. So, here either porcelain or a glass or a ceramics, what we call, were the choice for the higher voltages, and how this design came into the picture is very, very important. So, lot of effort was done for to see that this insulators were tried, and where this ceramic or glass insulators were initially invented by two important persons in 1907. One is the Harold Buck and of the Niagara Falls Corporation, and the Edward Hewlett, he is the engineer who was working in General Electric. So, these two people were the responsible for the early design of ceramic insulators for high voltage transmission. So, before that several trials were carried out, and finally the insulators which were used for the present day were modified a version of this insulator which were designed by Harold Buck and Edward Hewlett. So, later on, as the voltage levels grew up, people felt that ceramic or glass were bulky and also required lot of effort in stringing. So, they thought that how to reduce the weight and what could be the material which could be used for the replacement of this. So, somewhere in 70s people started trying it out, several type of non-ceramic glass type of insulators, which are basically known as a composite material or a polymeric type of insulator. So, the industry both in US and Europe started using various composite materials. Initially they started EPDM, later on they started using silicon rubber with several additive fillers and several of these things. So, this is how the newer technology of non-ceramic insulators or polymer insulators started to come into the existence. So, before going into the actual insulating part of the ceramic, glass or a polymer insulator, we would discuss about how these insulators are manufactured. So, we will see the ceramic insulators, manufacture of ceramic insulators, what are the important components which are required, what is the material which is required, what is the process which is adopted for the manufacturing of a ceramic insulator and also the polymeric insulator. So, today we will stop here. Thank you.